good morning to one and all. So today it's our second day of the FDP. I would like to call upon Mr. Ashish Awate, the Director and CMO of AIWIZ Tech Solutions Private Limited. The topic today he is going to discuss with us is interoperability of blockchain-based health information systems. Before that, I would like to call Dr. Madhuri Kulkarni ma'am to kindly felicitate Mr. Ashish Awate. So please come down. A big hand of applause. Thank you, sir. Thank you, ma'am. Now, without wasting the time, I would like to hand over the session towards Mr. Ashish Awate.
Okay. Very good morning to everyone. I am Ashish Awate. I am here to deliver a session on interoperability of blockchain-based health information system. So, we'll discuss this topic after a few minutes. Before that, we'll actually continue our last topic and finish it quickly so that you will understood the things. So basically yesterday we have seen the personalized medicine system. So just quickly recap what is personalized medicine means. It is a system, blockchain, AI based and digital twin based system which we discussed yesterday. Out of that, we have implemented yesterday the the blockchain-based system. That is where we created block using SHA. Then we have mined that block and we have stored the patient data, which is we have generated using synthetic data, or you can say a random function of Python. So we have stored it. Then we have seen there are two technology required so that we can give the patient a personalized medicine. The first is AI based, where we use the machine learning model, and second we have to use a digital twin methodology where we have to continuously monitor the patient using digital twin, where we create the avatar of that particular patient, monitor his vital signs, monitor his medicines, monitor his or her responses towards the medicine, and then according to that we can change our medicines, we can change the method of treatment, we can adapt or we can give the different kind of medicines if the patient is not responding to particular medicines. So we have seen that. Now we are going to see some of the slide is not there. Okay. So we will see the real world application of this personalized medicine. The first is cancer treatment personalization. It is we have to use here the genomic data analysis with the blockchain security. So the example you can actually is it visible to everyone? Last. Okay. So the Memorial Solan Catering's Watson for oncology. So basically here in this they have used IBM Watson technology and the oncology technology to find out the cancerous tumor in the brain, and as per the location of tumor they have find out the genomic data of patient and store it in a blockchain security, and on that they have used AI, and based on that they have actually do the treatment of this cancer. So this is one, or you can see this example, you can learn about this. There are many papers on this particular treatment. Second is diabetes and hypertension monitoring. So to do this, so this is our disease that is diabetes and hypertension, we can create a solution using IoT sensors, AI prediction and blockchain storage. So here the sensors will give you the real-time monitoring of a patient. AI will predict the level of diabetes and hypertension and categorize it into different levels. And blockchain is used to keep the security of data, also the consents of the patient. So the example is shown over here in this. This is the device that is the IoT sensors which take the data and send it to our UI or mobile application where we monitor that data, and these are the analytics of the patient. So one of the example is Medtronic's continuous glucose monitoring system. You can go on Google, you can search about this, you will get the knowledge of how you can do this. Second is in a pharmacology or pharmacy. Basically it is used to find a drug discovery and development, that is accelerate the pharmaceutical research. So this is the system of DeepMind's, or you can say a Google system, AlphaFold protein structure prediction. So this is the AI driven molecular analysis with secure data sharing. So here we will collect the data, then we synthesize, and finally we get the protein of each our system. Nowadays if you see the advertisement of different protein available, that is available for even for a patient, like so either you can sit. There is a chair, I think. Right. So here we want to find out the protein, which is actually, if you know that each and every person requires a different form of protein or different structure of protein based on their DNA. So based on this, we can generate a personalized protein tablets for them or protein powder for them. So based on the different things. So next is clinical trial management. So whenever you do the clinical trial on patient, so here we have to do the patient recruitment and data integrity. The solution for this is smart contract for consent, AI for patient matching, and the example for this clinical trial management is IBM's clinical trial blockchain solution. So here the last one is supply chain transparency. So here the counterfeit of medication. If you see that even many from last few years in Smart India Hackathon, this problem is coming. That is, you are transferring the medication from actually collection of the chemicals to the customer. So this is the supply chain. In that there are many times happen that the duplicate medicines are actually added with the original ones. So here we can use end-to-end tracking with a blockchain verification so that we can avoid the counterfeit medication. And the example and the biggest player in this area is MediLedger network by Chronicle. So this is how they maintain their blockchain network, from development of medicine to the transport and where it reached to the customer. Then there are some challenges and solutions over here. So first challenge in a blockchain based system is scalability issue, where you can blockchain transaction throughput has some limitation. So we can add the two-layer solution, a hybrid architecture and shading technique for distributed processing. Second problem is interoperability, which we discussed today. That's why I have actually working on it. So what happened with the interoperability? So there is a data for with the hospital 1 of patient of n number. Hospital B has a data of M patients with a different format. So hospital B keep it in a CSV, hospital A keep it in a JSON. They have keep first name, last name only. Hospital B keep first name, middle name, last name. So this creates a data conflict. Okay. Even there is a possibility that hospital A and hospital B both has same or redundant patient. At that time, what happened? Your data or your machine cannot identify that, because hospital A keep first name, last name and middle name, and hospital B keep only last name and first name. So because of that, it is not identify that these are the same patient or a different patient. There might be a possibility that two patients have the same name. That is, my name is Ashish Awate. There might be in this world, there is a chances that there is a probability that the same name person might available with the name of Ashish Awate. So that is why, so different healthcare system and standards in this world. So there is no one standard to keep the data of the patient. That's why there is one solution called Fast Healthcare Interoperability Resource, which we see today. This is the standard. Next is we can use API gateways for system integration, but this is very difficult nowadays because because of data privacy. API gateway requires many compliances of government, standardize the data format and protocol. So these two are the best solution for that. API gateway, it is far away right now because governments or the world government, even WHO has no standard to keep the data in hospitals. Okay, and no one can follow that. That's why even the software developers has no data structure or any fixed, you can say a fixed data format to keep the data of patient. That's why this is the great challenge nowadays. Next challenge is the data privacy, that is balancing transparency with patient privacy. So the solution is zero knowledge proof, homomorphic encryption and differential privacy technique. Then if you want to create or want to do the research in this area, blockchain based healthcare, so you have to compliance or you have to understood these three compliance requirements. First is Health Insurance Portability and Accountability Act of Government of US, that is patient data protection. Second is General Data Protection Regulation by European Union, that is data privacy regulation. And last, these two are used for blockchain, and last one is used for AI and ML in medical devices. It is the FDA. This is three you have to remember. This FDA is for food and drug, and you have to keep during the AI and ML model you have created. During that you have to keep the guideline of FDA. So whenever you mention or you use for healthcare, you have to mention that I have followed this guideline. Otherwise, you cannot actually, your paper or your research cannot be accepted worldwide. So you have to do the built-in compliance in your framework. So if you see that, or I have sent you one IPNYB file, I don't know whether it is shared with you or not, but basically in that I have implemented this particular compliances and then I have stored this data. Then there is an ethical consideration during the development of this system, that is algorithmic bias, ensure that a fair treatment recommendation, informed consent, that is transfer AI decision making and data ownership. Please remember that here, whatever data you use, don't think that it is your data. Always and always, whenever you use a healthcare data, it is under the control of patient. You have to take the consent of patient before using it, or you have to take a consent of hospital before using it. If you use directly, it might get you in the jail, okay, sometime. So this is ultimately. Now, what are the emerging technologies which we can incorporate with this? Because we have seen the three technology, that is, first is your blockchain security, second AI driven to take a data decision, third is data twin to give the recommendation or continuous monitoring of a patient. Other than that, after 2030, there is a large emergence of this computing integration that is called quantum computing. Still it is available, but it is not that much. But when we reach up to the quantum chip and quantum chip get chips, so then it is actually available to everyone. So when it is available to everyone, it has a potential to solve your simulation, which is now take 1 hour. It takes only 1 second. Okay, so that much computing power the quantum computer gets. So it is exponentially improvement in AI processing. The applications are complex molecular simulation, and after 5 to 10 years it is available with you. So you can start learning the quantum computing from today itself, so that when it is available you can utilize it with your AI models. The next, after 5G, there will be a 6G network which has the ultra low latency, massive IoT connectivity, because after this, now we are at industrial 4.0. Now after 6G, we will go to the 5th generation of IoT or Internet of Things or Industrial Revolution. So the impact is real-time health monitoring can be easy, and it is the edge computing for instant AI response can be done. Nowadays, we use a cloud computing, but AI edge computing is it hard to implement because of it requires low latency and rapid response. So it is not possible by 5G, or it has a limitation. But as soon as 6G came, it will be helpful to you. Next, after these two technology, quantum computing and your 6G came, you can use a brain computer interface which actually direct the neural signal processing. It actually helps you to mental health monitoring and treatment. But only challenge is that because it is a neural, or what happened whenever the neural came, we thought that whenever neural is there,